This is video number 19 on the foundations of arithmetic, algebra, and graphing. I'm Bill Kinney. It's part 8 of a sub-series called the Arithmetic of Rational Numbers, also known as fractions. And in this video, we're continuing what I talked about in the end of the last video about how to divide fractions. This particular topic is pretty important to me. It's my dad, who was also named Bill Kinney, I'm a junior, passed away in 2010. I admire him very greatly. He wasn't at all mathematically inclined, or so he said at least. And part of the reason was that, what he told me, the story was that when he was in 4th grade, I believe, his teacher was trying to teach him how to divide fractions and told him the usual algorithm to invert and multiply, which I illustrated here. Ultimately, we took 1/12 divided by 1/8 here to get 2/3 by doing the invert and multiply right there. And he asked the teacher why, and the teacher couldn't explain it, and that sort of soured him on math forever after, at least in this life. Maybe in heaven he'll enjoy math there. Anyway, what I tried to do in the last video was to try to justify why you do this invert and multiply in two ways. First of all, we tried to figure out the answer to this question about the pie, about how I cut my pie into 12 equal pieces over there, whereas the box said, you know, based on the serving size, you should cut it into 8 equal pieces that were 540 calories. Essentially, to figure out the number of calories for the smaller pieces that are 1/12 of the pie, I was, by the picture, trying to justify that the answer is 2/3, because, well, 2/3 of the pie and ultimately 360 calories, because I could break each of these pieces up into 2 pieces for 24 small pieces total, and each of these pieces into 3 pieces for 24 small pieces total, to see that my piece that was 1/12 of the pie is 2 of those smaller pieces, whereas this piece, which was 1/8 of the pie, was 3 of those smaller pieces, and therefore this one was 2/3 of this one. And you just see here initially, as far as the justification goes, that when you do this inverting and multiplying, 1/12 divided by 1/8 is the same as 1/12 times 8, which is 8 over 1. It does give the same answer, 2/3. This piece is 2/3 as big as this piece, and therefore the number of calories of this one is 2/3 as much as this one. Then I also try to give another justification for it. Doing 1/12 divided by 1/8 is really the same as, you can think of it as a fraction, 1/12 over 1/8. And since 1 is the multiplicative identity, if I multiply any number, including a big fraction like this, by 1, I should get the same quantity. And I used what you might call a disguised form of 1, a little trick that I used to multiply the top and the bottom of this by 8, meaning the whole thing by 1. And after doing that in both the numerator and denominator, the denominator became a 1 because the 8's canceled, divided out, and the numerator became the same thing, 1/12 times 8 over 1 that I had down here, ultimately giving the same answer of 2/3. And that was another justification for that. What I'd like to do in this video is look at another application of this, and because it's another application, maybe it'll help make more sense out of this. That's my goal here. And looking at my budget, I noticed that I spend 3 out of every $25 I make on food, and 1 out of every $20 I make on fruits and vegetables. I could have picked snacks there or something, but we'll try to be healthy and we'll pick 1 out of every $20 on fruits and vegetables, I guess. I was paying for it with the French silk in the previous problem. If I spend $7,200 on food during a year, how much do I spend on fruits and vegetables? So I spend 3 out of every $25 I make on food, and 1 out of every $20 I make on fruits and vegetables. Before we try to answer this question of how much do I spend on fruits and vegetables, just think about something up here. 1 out of every 20 is a smaller quantity than 3 out of every 25. That should make sense. 1 out of every $20 is the same as 2 out of every 40, for example. It's it's definitely spending less money on fruits and vegetables, which are, of course, food, than what I spend on food overall, and that should make sense too. I spend 3 out of every $25 on food overall. You could also think of this in terms of out of every $100. And this is getting into concepts of proportionality and percentages, actually. If I spend 3 out of every $25 on food overall, that's the same as 12 out of every 100. 12% really of my budget goes to food. If I spend 1 out of every 20 on fruits and vegetables, which again of course are food, that's the same as 5 out of every 100, or 5% of the money I make on fruits and vegetables. I hope it makes sense to you that if I take the ratio 1/20 and divide it by, and I'm going to write this as a fraction, divide it by 3/25, that fraction of fractions, which again is okay to do, the numerator is a fraction, a rational number, and the denominator is a fraction, will represent the proportion of the money that goes toward food, well, of that, I'm saying this wrong, of the money that goes toward food, of the $7,200, that's the proportion that goes toward fruits and vegetables. So I spend a certain amount on food, it's the $7,200. A certain fraction of that number gets spent on fruits and vegetables. So, and it's this thing right here. And so if I multiply this by the $7,200, ultimately, that's going to give me the answer to the question. Now come back here. Let's do the algorithm for doing 1/20 divided by 3/25. The algorithm, the procedure, is to invert and multiply 1/20 times 25/3. You keep the first fraction the same. You take the second fraction, you invert it, and you multiply instead of divide. This is the same as 25/60, which is the same as 5/12. I also could have seen that by dividing some things out. 20 cancels with the 25 to leave a 4 and a 5. It's the same as 5/12 there as well. So 5/12, not quite half of my food bill, I'm pretending, at least as fruits and vegetables. I actually didn't look at my budget for this, I just made up these numbers. It's almost half. So the answer here in the end is going to be almost half. In fact, it'll be 5/12 times $7,200. It'll be almost half of that. It'll probably be over 3,000, or maybe around 3,000. In fact, 12 goes into 72 6 times, so it goes into 720 60 times, and 7,200 600 times. In fact, this is coming out to exactly $3,000 as the answer to the question. Oops, 3,000. Coming back to the ratio here, in the minute I have remaining or so, let me just show you the other way to think about it that I showed you in the last video. I could multiply this whole fraction by a disguised form of 1. What should I pick? Should I pick 25 over 25? I could. I guess I will. Reason being is that then when I multiply this through in the top and the bottom, on the bottom the 25s do cancel. They divide out with each other. On the top I've got 25 over 20, which is the same as 5/4. I'm dividing that by 3. I guess I haven't fully explained this like I was hoping here. I'm dividing 5/4 by 3. It should make intuitive sense that that's the same as taking 1/3 of 5/4. Like if you've got, well, $120 and you divide it by 3, that's $40. That's the same as 1/3 of $120. This becomes 5/12. It's just another way of seeing that you get 5/12 in the end. I'm not sure which of these might satisfy you the most, but hopefully you are starting to understand intuitively why you do this algorithm for inverting and multiplying when you divide fractions.